Mike Stice has spent a lot of time and just has single-handedly put these next three panels together and has done a masterful job. And he's going to introduce the panels. Let me just say a few things about Mike. Our next three panels, we're going to be talking about seismicity, water management, and carbon issues. And Mike will be moderating one of the sessions, but he put all three of them together, really. He's a University of Oklahoma alum. Many of you know him. Really an energy leader with more than 35 years experience in this business. He began his career in Oklahoma, but he worked all over the globe in leadership positions during most of his career. He's one of those guys. I've known Mike a long time and has probably lived in more countries than most people I know. After serving as chief executive officer of Chesapeake Midstream Partners, which later became Access Midstream, he retired in 2015 and accepted the position as dean of the Mewburn School of Earth and Energy at OU. And OU is very fortunate to have a man like Mike on board. He earned his chemical engineering degree from OU in 1981, master's degree in business in 95 from Stanford University, and an international director's diplomacy from Sydney University in 97. He also completed his doctorate in education at George Washington University. So I'm looking forward to see what he's got on his plate next education-wise. I'm going to turn it over to Mike and let him introduce panel members and kind of tell you what he has planned.
Thanks, Jay. I'm going to let Keith load a few files. So Jay challenged me and specifically a number of the advisory board members to think carefully about what are the top three major challenges, as we heard earlier, what are the headwinds that might be facing some of the many things that you heard about in the earlier panel session. And I hope you picked up on some of the themes. You know, this transition from abundance or to abundance from scarcity is something that I can attest to. I mean, I lived that. I was a part of the supply committee in 2003. For those of you who aren't familiar with the National Petroleum Council, it's a committee commissioned by the president to ask the industry to tell us what the supply and demand situation here is in the U.S. And if you really want to have some entertainment, go back and read that study. Unfortunately, my signature is on that page. I've tried every which way to take it off. But the study basically said the U.S. oil and gas business is in trouble. There's no additional supply. The light's going to go out. We need to go find LNG elsewhere. And I believed it so much, I changed my career and moved to the Middle East and started building a major LNG facility. Wow, how wrong could I have been, right? And so we went from a very scarcity mentality from our perspective on supply demand to an abundance mentality, largely due, as many have pointed out here, to the shale revolution and the independent sector using technological innovation. So that's the other piece that I want to be careful to remind you guys of. Technology is always underestimated. Technology was underestimated here domestically. It's been underestimated in all the manufacturing businesses that Mike Ming was giving you examples of, or some of the physicist perspective that Mark Mills was talking about. I always find Mark's comments very intriguing. So I think it's important for us to, as we think about the challenges that we're going to present here, namely induced seismicity, water, and carbon, that we think about the role technology is going to play. Once we understand these phenomena, once we get into the data and apply our best efforts, where this might end up, okay? But it's fair to say that today we might be looking at these issues with some stark reality that these issues are bigger than what we are today. We've got bigger problems, and we've got to figure out how to manage it. So Jerry Boak, who is our own director of the Oil and Gas Survey, Oklahoma Gas Survey in my office, but specifically works for Secretary Teague, has joined us to moderate a panel on induced seismicity. Most people think this is an Oklahoma-only issue. It is not. It is an issue that pertains to not only other states, but also in Canada. And so this issue and understanding it is going to have much greater implications than just here in Oklahoma. Kyle Murray will then be coming up and moderating a panel on water, and we have a number of very distinguished guests to talk to you about that. And then I will be leading the panel on carbon. So we'll be taking these in that order. And so with that, I'm going to introduce Jerry Boak so he can introduce his panelists.
Thank you. It's a pleasure to be here. I have both of my bosses, both of whom are named Mike, here with me. I've got Dean Stice and I've got Mike Teague, the secretary. It's a pleasure to be talking about this topic. And while it's not just about Oklahoma, it's something like 85% of the earthquakes that are now considered to be associated with oil and gas operations have happened in Oklahoma. The other reason I'm pleased to be here is that I had an interesting insight sitting here listening to these panelists, and that is that innovation keeps paying back, sometimes for hundreds of years. A single innovation doesn't just pay off once, and the innovation put in place by our founding fathers, which said, you know what, the earth does not belong to the crown, has paid off, and it's the single most important influence on the development of these resources that people call shale, but which are really tight rock resources. Speaking as a geologist, I don't want shale to lose its entire geologic meaning. In fact, most of the production from the Bakken, from the oil-producing horizons, does not in fact come from shale. It comes from fine-grained, tight rocks that are equivalent to the tight gas sands that we've been producing for many years. I have here Mike, who's our Secretary of Energy and Environment. He says he's not a technical guy. He doesn't understand a lot of this stuff, but that just makes him a quick learner. He's been really impressive at identifying the relationship, first of all, between energy and environment, but also at picking up all the various elements and looking at ways to bring together people who are talking about all kinds of energy. It's really difficult from the oil and gas side to talk to the renewable folks, from the renewable side to talk to the oil and gas folks, but he thinks across that boundary, and that's very exciting to work with. Jake Walter, recently had the pleasure to hire as my state seismologist. It's a title we really invented as the seismicity ramped up here in Oklahoma. We managed to steal him from Texas, and I'm learning quickly how important it is to steal things from Texas when you're in Oklahoma. I'm not a native Oklahoman, but I have learned a great deal that any coup you can pull off with respect to Texas is important to Oklahomans. I already had an offer out to someone, but I wasn't sure I was going to get him when Jake called me and said, "Is this position still open?" And I said, "Well, I've got an offer out, but get your application in." And it worked out great because I really had a good time in the time I had a chance to work with him. I'm going to start this session with a little bit of tutorial or a little bit of a description of the earthquake problem here in Oklahoma. And if I were in Washington, D.C., I would have to say that I was unpacking that issue for you. But luckily out here, we don't have to worry about the language fashion police. Can I? Yeah. Okay. So here's a map of the 2016 earthquakes in Oklahoma, and it highlights 3 magnitude 5 earthquakes. Those of you who are Californians are welcome to sneer at the magnitude of our earthquakes, but in fact earthquakes in the mid-continent have very strong felt areas. Earthquakes in the New Madrid area of Missouri caused church bells to ring in Boston. So there's serious damage caused by these larger earthquakes. There's a whole new question been raised about the collection of relatively modest earthquakes here in Oklahoma. We don't know much about what happens if you have one that causes a crack in your foundation or your wall, and then 50, 60, 70 magnitude 3 earthquakes that just keep shaking that same spot. The structural engineers themselves say they don't study this. But we had 623 magnitude 3 and larger earthquakes in Oklahoma last year. The shaded area is the area of interest related to earthquakes defined by our Corporation Commission, our partners in trying to address these issues. We're lucky we're not the regulator. They're the ones who have to make the tough decisions. The earthquakes are happening deep within the crust, well below oil and gas operations, so it was challenging to put the finger on oil and gas operations as being the cause of it. They're happening in directions that are favorably oriented. The earthquake motions are in directions favorably oriented to the stress field in Oklahoma. And they are also strongly correlated to the blue and purple dots on this, which are the large injectors that are disposing of salt water produced along with oil and gas in this area. And it's most 90 to 95 to or more % of the water being disposed of is formation water, ancient seawater. It's highly saline, saltier than the Dead Sea, and it is not frac flowback. That's the remaining 3%. You can see here that the earthquakes, the bars, rose just a little bit starting in 2009, but really ramped up in 2013. And leading that was a very substantial ramp up in the amount of this salt water being disposed. That's the dark red curve up above that. That peaked sometime in 2014, that injection. And it's a really interesting plot to look at the correlation between that and the initiation of a very substantial drop in the price of oil. After that injection dropped very drastically, more than 1 million barrels a day. It's interesting that for a long time, those data were out there, and the press and a lot of opponents kept saying nothing has been done. And yet 1 million barrels a day had dropped out of the injection that was interpreted to be the cause of this. And that was happening. It produced a somewhat of a decline for a while in oil production. That's the top curve. But in fact, oil production leveled out after a while because companies found other places to drill. Right now, we have some really exciting collaborations going on with industry. We're working with the Corporation Commission to try and understand better this process, not only for Oklahoma, but for a lot of other places in the world. And if we do, in fact, end up sequestering carbon, it's going to be an issue for them. But there are other plays that produce as much water as the ones in Oklahoma that did this. And we are now beginning to get some instrumentation to understand the pressure relationships that drive earthquakes in Oklahoma. The survey is also building a major database to kind of catch up with the modern world, get a lot of paper records scanned and entered into a computer system. We envision that as a major step forward for our efforts to collaborate and to get information out to the public and to our industry partners. So there are a lot of challenges for the future that are needed to address this issue. Better seismic monitoring, Jake will say a few words about that in a minute. Data management, as I showed, to understand water injection and earthquakes. Research into patterns and mechanisms so we better understand how this all happens and where it's likely to happen and where not. Better characterization of basement geologic structures. As someone who did his dissertation on the oldest rocks on the planet at the time, I know that Precambrian rocks, our basement, is fractured and broken up. There are faults everywhere. People try to say that the difference with Oklahoma is just so many more faults. I'm here to say it isn't so as a geologist. We want better geomechanical and hydrologic modeling. There are very primitive models out there that show this relationship, but they're still deeply flawed, and they require driving forces that aren't necessarily realistic. Another issue that the state of Oklahoma has been addressing is treatment and reutilization of produced water. Can we recycle some of this very salty water in useful ways? And I think we also need to enhance our emergency procedures and mitigation and remediation approaches. We have to address this question of what kind of damage happens when you have a lot of small earthquakes. I think that's it. I'll turn it over to Jake next. Is that right? Yeah.
So induced seismicity, we have a kind of clear 50-year record of studying induced seismicity. And this was going back to the Rocky Mountain Arsenal in Denver area, where wastewater was injected. USGS conducted some controlled experiments and found that the rate of water injection led to an increase in the seismicity rate, a clear correlation. So we have, sort of this track record of understanding this 50 years ago. Now, the difference in going from that to present-day Oklahoma is the scale of a few kilometers to hundreds of kilometers, in addition to having these moderate earthquakes in the modern built environment. And so this is a hazard to you if you're an Oklahoman who owns a home. This is a hazard even to the oil and gas industry, to the infrastructure, shaking from these moderate earthquakes. So I'm often asked whether these are just natural earthquakes. And the answer, is long-ranging, but in short, Oklahoma does have natural seismicity. In 1882, in the sort of southeastern corner of the state, there was a magnitude maybe 5.5 earthquake, the Choctaw Nation earthquake. There was a significant earthquake in 1952, about a magnitude 5.5 in El Reno, which is just west of here, for those not familiar with the area. Now, and if you look at, the OGS fault database, which Jerry kind of showed, you can see that there's, the state is crisscrossed by a myriad of faults. And so, yes, there is some level of natural seismicity. However, we believe at OGS, as well as the greater academic community, that a lot of the seismicity that we're seeing, the increase in the seismicity rate, is tied to the vast amounts of wastewater being injected into the Arbuckle Formation. Now, looking at some of the current trends has been the subject of ongoing work by myself, Kyle Murray, other OGS researchers, as well as the seismic team. And this is looking at not just locating the earthquakes, which we'll talk about in a second, but because we have to do that work too, but actually trying to associate earthquakes with injection wells. We found, when we look at some of the emerging trends in the data, the statistical correlations, that it's actually very difficult to tie individual earthquakes or earthquake sequences to individual wells. Because Oklahoma has been injecting such significant volumes for such a long period of time over a broad area, we really have to study the problem in a very holistic sense. Kyle Murray's efforts towards understanding the Arbuckle Formation and where that water is going is really kind of leading that effort. It's then that we can take what we know about the earthquakes being caused and correlate it with where the water is. So we need to improve our understanding of these systems. So the OGS seismic team, whenever we record or report an earthquake and it goes up on our website, it gets entered in the catalog, which the OCC uses to sort of monitor activity. Various stakeholders throughout the state utilize the OGS seismic catalog, and academic researchers utilize. That requires the efforts of a team of about 6 in our seismic team. And we're pulling in 100-plus seismic stations throughout the state. 20 of those we own. A good chunk of those we're actually borrowing from a national instrument pool, so that will potentially go away somewhat in the future. And then USGS also has some temporary stations throughout the state. So this is really, a big data problem. And we're using multiple servers to, get the tech that we need to really just do the very basic thing to produce this earthquake catalog. And the things that we can learn from the seismic waves, because these seismometers are recording the ground motion everywhere, and it's only when the ripple effect of the waves hit the station, we're able to triangulate and actually locate the source of the earthquake. Now, we need all these stations in order to find the very smallest earthquakes, but we can actually use supercomputers, which we're doing currently, to go through and scan the data and find the smallest earthquakes. Why is that important? Because we want to actually be in a position to better forecast larger events. When we applied this methodology to the Pawnee earthquake, which occurred last September, we found that actually in the days leading up to the earthquake, we found very small foreshocks that potentially, if we understand a lot of these sequences, we maybe could forecast that event in the future. Now, of course, this is only utilizing this technology and looking back in the past. Hindsight is 20/20, so we need to really kind of test this on other moderate earthquakes. And this sort of technique that we're using in Oklahoma has been applied to earthquakes, always looking in the past, though, like the Tohoku earthquake, the large Tohoku earthquake, some of the larger Chile earthquakes. So, I mentioned that, there's this promise of forecasting, using the smallest earthquakes to forecast future earthquakes. And the only way that we can do that is actually expanding the network. We need more stations in Oklahoma. This is particularly challenging considering we're a state and university entity in Oklahoma. And if you read the paper, we're having some budget challenges right now. So we need to kind of figure out creative ways to leverage funding to fund these types of endeavors, these broad statewide networks. At the same time, earthquakes don't just exist in the ether. The OGS has, in the past few years, has produced a sort of statewide fault map. This is important because this came from a lot of industry contributions to this fault map. So we'd like to continue that effort. In addition, as we build up this broad, 100+ stations, expand it even more, we do tend to find small earthquakes associated with hydraulic fracturing. And we've worked closely with OCC to get out ahead of that as the industry is shifting into the scoop and stack to really kind of mitigate those earthquakes before they become an issue. And the OGS's position is that the more significant seismic hazard is still associated with wastewater injection, but that we're closely monitoring earthquakes throughout the state, natural or induced. And so I think that, what will come out of all of these efforts and the OGS research is that Oklahoma should emerge as sort of a leader, which utilized academic collaborations with industry to really get out ahead of this induced seismicity issue. And I think that, that can be applied to other regions, as Dean Stice alluded to.
All right. Now I'm going to turn it over to Mike Teague, who takes on the sort of as the boss for the regulating group and as the perspective of the political aspects of this issue.
Yeah, I wouldn't say the boss of the regulated group because 3 commissioners might come after me.
Oh, that's true. Sorry.
Jake kind of finished on the idea of collaboration, and he was talking specifically around, expanding the seismic monitor network. But really, you need to understand the collaboration that's been going on around induced seismicity for probably the last 2.5, almost 3 years. Dean Pullen talked about collaboration between industry and academia. I would add government to that, and you really, if you look at this problem, it has taken all 3 of those pieces working really well together. In September 2014, the governor announced or directed me to put together this coordinating council. And it's called Coordinating Council on purpose because it really is about not taking over any one agency or sector's role, but it's forcing the coordination between all of those groups. Kansas had a very similar earthquake problem. They had a task force. It was the Kansas Corporation Commission. It was their Kansas Geologic Survey, and it was the Kansas Department of Health and Environment. And the commonality is all of those people are paid by the state. Our coordinating council has those same entities, our Corporation Commission, our Geologic Survey, our Water Resources Board, and I know Kyle's going to talk on produced water, our Oklahoma Energy Resources Board, and I see Tim Munson standing in the back, all of our state agencies that have been working around induced seismicity and the oil and gas industry. We took a little bit of flack for that, and folks said, hey, you're letting the fox in the hen house. And my answer was, who do you think knows best what's been going on underneath the state of Oklahoma for the last 100 years, except the guys who've been stomping around looking for the oil and gas underneath it? Okay, it's worked really, really well, and I'll give you some examples of that. And then the third part of this was we brought our universities in. And for us, we brought in OU, OSU, and TU as our 3 Oklahoma research universities. But really what that enabled was I needed to be able to get out to all of the other work being done at Stanford and Cornell and CU Boulder and even that stuff going on in Texas. But we needed access to all of the rest of that academic community if we really were going to solve this problem. And so this group has been going since September of 2014. We meet every single month. All of those folks put that time to meet every single month. Okay, so examples of some of this collaboration. The very first meeting, Austin Holland was a state seismologist at the time, and he walked into the meeting and he handed out maps, and there were these 5 big red circles, and he said, I don't have fault data in these parts of Oklahoma. I need more information. The industry folks took those maps, and so we have OIPA and ACOGA as our industry reps. They took copies of those maps, and we now have filled in the majority of the fault data, I would suggest off of your map, came from that industry data. And how much do you think the industry charged the state? Zero. Okay? This was about collaboration to solve a problem. We got the correlation tied to disposal wells. Corporation Commission regulates disposal wells for the state of Oklahoma. That's delegated from the EPA. And they said, we need to increase our reporting requirements. And so they increased reporting requirements and reporting frequency and had no place to put the data. We said, all right, we've got to figure out a database to fix this so we can actually use this data. But we had some industry folks sitting in a room, and they said, what would make this easier is if you had electronic filing on the front end of this. And it would make it a lot easier for us as operators to get you that data, and it'd be more accurate. And we had researchers in the room who said, I don't care how you put it in the database. We want the data on the back end, Kyle. Okay. So instead of fixing this problem, we fixed this problem. Okay. And I'll ask again, how much do you think that costs the state? Zero. Okay. We funded that effort through the Groundwater Protection Council, the same NGO that does the Frac Focus database. We funded that with OERB money. We funded it with Department of Energy money, laundered through GWPC. And we now have this database. The very first volume restriction that the Corporation Commission put in place around induced seismicity was in July of 15, and I think it took us a month. It took a month to figure out where we were going to do this, and it was a really small area. Okay? It took a month. The day of the Pawnee earthquake last Labor Day weekend, that earthquake was at 7:45, and by 11:30 the Corporation Commission knew which wells needed to reduce their volumes because they were tied to that earthquake. That's cooperation. That's coordination. That's not anybody doing somebody else's job. That's just putting the right people at the table to say, we ought to all work together to solve this problem. It's worked really, really well. The pieces that Jake talked about around the seismic monitoring network, the research project that you talked about on wellbore pressure, and Kyle's project, that's cooperation between industry and researchers that then inform the regulators. And isn't that what we should be wanting? It's the only way we're going to solve this problem. And so that cooperation really has worked very, very well. There's a couple of future efforts. The digitizing the data is the other one I was going to mention. But if you think about this, why are we collaborating? And I'll go back to the Fraser Institute ranked Oklahoma #1 in the world for oil and gas investment, again. On top of, we had 907 frickin' earthquakes 2 years ago, okay? #1 again, and it should be because if there's a problem, you own it, you fix it, and you move forward, and I think that's exactly what we've done. So I want to make sure, I know we said we want to leave time for questions, and so.
Yep. Right now.
Schedule.
We'll open the floor for questions. And I will say, to even enhance what Mike said about collaboration, within 3 days of that first release on the Pawnee earthquake, the Corporation Commission discovered, we found a bunch of new aftershocks that said there was another fault that was moving, and they redrew again within a few hours.
Could you comment some more about the OCC decision to trim the injection rates based on the Pawnee earthquake event? Are they going to continue to take a location basis as a criteria for deciding to identify an injection location to be curtailed? What's the criteria for OCC to implement some reduction in
I would say that's evolved. So I said the very first volume restriction we did was around Logan County, really a pretty small area. We started with, if there's an earthquake, that's where we should base, that's where you're focused on trying to fix the problem. We drew, I think it was a 10-mile circle around the epicenter of the earthquake, and we reduced volumes in there. It wasn't working. I mean, we were still having, the number of earthquakes were going up. So we took this really broad area, the area of interest that Jerry showed on that map, and took that whole area and set a 40% volume reduction across that area. And so as the research evolved and said, hey, it's probably bigger than just these small bullseyes you're putting on there, then the regulatory solution evolved. And so it really was this area approach to the volume restrictions. And then the two changes I think have been on top of that area. #1 was the Pawnee specific that you're asking about. And so not only did that focus around the biggest earthquake in the history of the state, but it also, for the first time, impacted disposal wells in Osage County, which are not regulated by the Corporation Commission, regulated by EPA, which is another really strong partnership that most folks don't understand. About 2 hours after the Pawnee earthquake, I got a phone call from the EPA regional administrator in Dallas. But most state folks don't want their federal partners calling them. And remember, I was the federal guy for a long time. That phone call went, hey, Mike, it's Ron. What can I do to help? Right? That's a partnership. It was really, really helpful. So I think that's the area or the piece of that changed around the Pawnee quake. And then the last piece that the latest directive that the commission put out, as we looked at what really was driving the disposal volumes down, their commission had taken these volume reductions, but really it was the commodity price, right? So I think 2 months ago, probably my numbers, we were at about 1.5 million barrels a day is what the actual disposal was. The permitted amount was 4.5 million barrels a day. And so if the price went up, were we now going to increase our volume again and be right smack back in the number of earthquakes that we had before? So the commission capped every one of those wells at either 10,000 a day or 15,000 a day, depending on where you were in this area. And that brought that permitted amount down. There is some room for increase, but not as much. And so trying to be proactive, how do we prevent getting ourselves back into this problem? But the Corporation and Commission really has evolved as the research has evolved.
Okay, I like to warn you, I love earthquakes. And I'm going to try to explain you from where I'm coming. When you do the injections of product, you essentially inject energy. And the secret is that in order to avoid earthquakes, if you want to, is to make sure that you spend that energy in the reservoir. Now, how do you spend energy? Via strain energy, via the movement of little faults, little fractures. That if you can tolerate small earthquakes, in your case less than 3, that means that you have a way to distribute that energy to inject. Recently, I have been using some models, some that were mentioned from geomechanical coupled with fluid flow, and you can manipulate where the strain energy is going to be dissipated and try to avoid areas where the energy does not dissipate and accumulates, and finally you have a large earthquake. That there is ways now to do this, and my question is, why don't we use that criterion rather than putting a circle of about 10 miles around the well?
Yeah, well, so the USGS, after the Rocky Mountain Arsenal, they also ran another controlled experiment in Rangeley, Colorado, where they, again, they sort of metered out the injection and looked at the earthquake rates. And, in the discussion section, there was a kind of a thought experiment. What if on the San Andreas Fault, you had every 5 kilometers you had an injection well, and you could inject within that 5 kilometer section water and then pump out the water on either ends of that the next 5 kilometers. So you, in a sense, you would have these 5 kilometer sections slipping, because 2 centimeters of slip on a 5 kilometer fault results in about a magnitude 4.5 earthquake. So that's an old idea, but I think that to implement that in anywhere would be somewhat reckless. Partly because we have an incomplete knowledge of the subsurface. The Pawnee Fault ultimately ruptured on a fault that we didn't know about. I don't think that we're advanced enough to understand earthquake cycles, earthquake rates, and their interactions with adjacent faults or fault stepovers, that we could really minimize the risk associated with some sort of geoengineering project on natural faults. I just don't think we're there.
Right now, less than a third of our earthquakes are located within 2 kilometers of a known fault. So we don't know where the faults are yet.
Correct. By the way, the Rangeley oil field or the Rangeley experiment, that was pore pressure. It was nothing to do, nothing else. It was on that site. The Rangeley.
Yep, the Rangeley?
Rangeley earthquakes in Colorado.
Yes.
That was a pore pressure control.
Pore pressure control, yeah, but they also measured the fluid injection, as I understand it.
Yeah. By the way, the saying that you don't know the basement, that's correct, but you can always go using
Stochastic methods, or yeah.
Yeah.
And that's really the point that we want to be in Oklahoma, is really apply some of these stochastic methods so that we can get in a position where we can mitigate proactively. I think that's the ultimate goal, but whether that takes a decade or I don't know.
When you have 900 magnitude 3 and larger earthquakes and a population that is upset, the first objective is to reduce the overall injection and tamp that seismicity down. And we have seen it decrease in all areas. I think that's the first action.
I agree with you, but you can manipulate. That's what I'm saying. Those new technologies that we have into the modeling, you can manipulate and move the seismic relaxation at your pleasure.
A great discussion for Norman sometime. We'd be happy to talk to you.
And
Can
let me facilitate just real quick. I think it's important to recognize some of the comments that all 3 panelists have made, and frankly, JC, yours too. The answer here is going to come from additional data, additional study. I like Jake's comment about we're not advanced enough to make some of those precise decisions. I hope we get there at some point. But I think the encouraging part is the government, industry, and the academic world here is investigating this thing to the best of their ability and actually seeing some traction and working together. But this is one of the significant challenges facing this industry. We have to figure out how to work together and make sure that the common good, the general public's interests are taken care of. And so I want to thank my seismic panel, and I'd ask the water panel to make their way up while I make some introductory remarks. Thank you all very much.